Chemical reactions. A chemical equation is a symbolic representation of a chemical reaction. Here's an example. Hydrochloric acid and sodium hydroxide yields water and sodium chloride. Hydrochloric acid and sodium hydroxide are the reactants in the equation, and water and sodium chloride are the products. Law of conservation of matter. Law of conservation of matter states that matter is neither created nor destroyed in a chemical reaction. Energy can be transformed from one kind to another and from one object to another. Balancing chemical equations. When balancing equations, the number of each type of element on the reactant side must be equal to the number of each type of element on the product side. This is done by adding coefficients. Here's an example. Silver nitrate and potassium chromate react together to produce silver chromate and potassium nitrate. The first step would be to write each molecule out in elements, or symbol form. Silver nitrate would be AgNO3, potassium chromate would be K2CrO4, silver chromate would be Ag2CrO4, potassium nitrate would be KNO3. The second step is to write out the unbalanced equation. AgNO3 plus K2CrO4 yields Ag2CrO4 plus KNO3. The third step is to make a chart of the number of each type of element or polyatomic ion. On the reactant side, K has 2 and the rest have 1. On the product side, Ag has 2 and the rest have 1. As you can see, chromate and nitrate are already balanced and both have 1 atom on both the reactant and product side. However, Ag has 1 atom on the reactant side but 2 on the product side, and potassium has 2 atoms on the reactant side and only 1 on the product side, making this equation unbalanced. The fourth step is to add coefficients to make the number of each type of element or polyatomic ion equal on both sides of the equation. First, cross off the 1 in the reactant side of Ag in the chart. This causes a 2 to be in front of AgNO3 in the chemical equation. Since the Ag is next to the NO3, this also causes the NO3 to have 2 on the reactant side of the chart. Since there is now a 2 on the reactant side for NO3, we must put a 2 on the product side for NO3 as well. Therefore, the 2 goes in front of KNO3. This causes K to become 2 on the chart, making the whole entire equation balanced. Chromate doesn't need to have anything done to it because it is already balanced. The balanced equation has a 2 in front of AgNO3 on the reactant side and a 2 in front of KNO3 on the product side.
Created using Powtoon.